Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to talk about acid nomenclature, or in other words, how to name acids. So let's get into this. So remember what I said in my previous video. There's two types of acids. You have binary acids and you have oxyacids. Binary acids are those acids that have hydrogen and some other element. It's only got two, so that's why it's called binary acids. And then you've got your oxyacids, which has multiple atoms bonded together, one of which has to be a hydrogen. Another one is some other element plus oxygen, therefore it's called an oxyacid. So there's two different ways of naming those acids. One way of naming binary acids, another way of naming oxyacids. So I'm going to go over both of those right now. So let's start with the binary acids. So binary acids, again, are those acids that have hydrogen plus some other element. So the way you name binary acids is that you start with hydro in the name, hydro for hydrogen, right? So that this part of the name takes care of the hydrogen part of the name or the formula, because all of these begin with hydrogen. So you got hydro plus you're going to take the root of the name of the second element, whatever that is. You're going to drop off the ending and you're going to add IC to it and then add the word acid. So you're going to have hydro for hydrogen. You're going to take the root of the second name, or the name of the second element, add IC to it, and then add the word acid. So let's take a look at these binary acids here. So first, I want to go back to naming your binary compounds. If your acid or if the compound is in the gaseous form, we typically name those like they're binary covalent compounds. So how did we name our binary covalent compounds? Well, we took the name of the first element and then we add the name of the second element with the IDE ending, and then of course you have your prefixes. So remember, for uh, for the compounds that have hydrogen plus a halogen, those can be named without the prefixes. But typically, when we're naming our covalent compounds, our binary covalent compounds, we're using prefixes to identify how many of each element you have in your compound. So typically we would use mono for one, and whenever you have one of the first element, you don't use mono for the first element, but you will use it for the second element. However, for compounds that have hydrogen plus some sort of halogen, you don't need the prefixes. You can write it without the prefixes. You can add the prefix in, or you can leave it out. So so for HCl gas, you can name that as just hydrogen chloride, the names of the two elements. Notice that you have this name of the first element, hydrogen, and then the name of the second element, but you got to drop the ending, keep the root, chlor, and add IDE, right? So you got hydrogen chloride, or you can add the prefix mono to the chloride to indicate that you only have one. So you can name it hydrogen monochloride. So both of these names are acceptable for this if it's in the gas. So remember, these have to be in gaseous form. So HBr gas would be hydrogen bromide or hydrogen monobromide. For HF, it would be hydrogen fluoride or hydrogen monofluoride. So that's how you would name your binary covalent compounds if you begin with a hydrogen, and then you have some sort of halogen. Now, if they're in aqueous, then we name it like an acid. So HCl aqueous, we're going to name that like an acid. So we're going to follow this. So hydrogen starts, so since we have hydrogen, that's going to be hydro. Hydro for hydrogen. And then chlorine here, we drop the ending. So we're going to take the root chlor, drop the ending ine. We're going to have chlor, and then we add ic. So chlor followed by ic. So hydro for the first hydrogen, and then chlor for chlorine, add IC, so chloric, and then we add the word acid. So HCl aqueous is hydrochloric acid. And that's how you name your binary acids. So if we look at HBr aqueous, again, hydrogen is hydro, so hydro for hydrogen. And then we have bromine, where drop the ending, add IC, so bromine becomes bro or brom. So we're dropping INE, add IC, and we have acid. So bromic acid, hydrobromic acid, all one word, hydrobromic acid. Or two words. This is one word, this is second word. Finally, we have HF aqueous. So HF, H hydro. So we have the hydro for hydrogen. And then fluorine, drop the ending, drop INE, add IC. So fluorine becomes fluoric. So fluor is the base, and then add IC, and then add the word acid, hydrofluoric acid. And then last but not least, if we have HI, right? So HI is kind of special. It can be two different names, very close to each other. So what's commonly written is, again, hydro for H, so hydro for hydrogen. And then iodine or iodine, drop the INE ending, add IC. So iodine becomes iodide or iodic, sorry. So iodine becomes iodic. So we have iodic acid. Iodine becomes iodic, and then you have the word acid. So hydroiodic acid. In some places, you might see it named slightly differently. So in some places, in some textbooks, you'll read that for iodine, we drop the O of hydro. So hydro drops the O. So instead of hydro, you have hydro with the R, and then you add iodic. So hydriodic. So hydriodic acid is also the name of HI aqueous. So you can name this hydroiodic acid, or you can name it hydriodic acid. So both names are acceptable. Okay, so that's how you name your binary acids. So hydro, the root of the second element, add IC to it, and then the word acid. Okay, now what about oxyacids? So oxyacids are going to name different. So the big thing here is there is no hydro at the beginning of an oxyacid's name. So don't add hydro. You're going to take the polyatomic ion of this acid. So remember what I said before. The oxyacids really are polyatomic ions that have hydrogen added to them to balance the charge, right? So if you look at the name of the polyatomic ion in your oxyacid, what you're going to do is you're going to drop the ending. So the polyatomic ion is either going to add in 8 ATE, or it's going to add in IT. So what you're going to do is drop that ending and add either IC or OUS, and then add the name acid. So which one do you add? So you're going to take the root of the polyatomic ion. The root of the polyatomic ion is what you have after you remove the ATE ending or the ITE ending. And then you add OUS or IC to that to replace that ending. So how do you figure out which ending to add? Well, if the name of the polyatomic ion ends in ATE, you're going to drop it and add IC. If the name of the polyatomic ion ends in ITE, then you're going to drop it and add OUS. And then you're going to add the word acid. So let me do a couple of examples to show what I mean. So here I have HNO3. So I'm going to ignore the hydrogen and just focus on what's left. And what's left is a polyatomic ion. So here I have NO3. You have to know what the polyatomic ion name is. So NO3 is nitrate. So nitrate, NO3 minus, is nitrate. So HNO3, well, how do I name that? Well, I'm going to take the name nitrate. It ends in ATE. So I'm going to drop the ATE ending and I'm going to add IC. So then I'm going to drop this and then it becomes nitric. So nitrate becomes nitric and then I add the word acid. So HNO3 is nitric acid. So far, so good? So let's go look at HNO2. Well, NO2, oops. Sorry about that. So NO2 minus is nitrite. So it has an IT ending. So for HNO2, I'm going to drop the ITE ending here and add OUS. So then ITE gets dropped and I get NITROUS, nitrous. So nitrous, and then I add the word acid. So HNO2 becomes nitrous acid. And that's how you name your oxyacids. Now, before I end this video, there are a couple of things I want to go over with regard to oxyacids. The roots you have to remember. Some of them you have to memorize. It's not as simple as just dropping the ending and adding IC or OUS. Sometimes the root, you have to remember what the root is. So let me go over a couple of examples. So let me do, for example, H2SO4. So H2SO4, I'm going to name that the same way I did before. So so I'm going to ignore the H's and I'm going to focus on what's left, and that's the polyatomic ion SO4, which is sulfate. So I take sulfate, excuse me. So you would take the sulfate, and as I said before, if it ends in ATE, you drop the ATE ending and you add IC, right? So sulfate becomes sulfic. So this should be sulfic acid, right? That would be wrong. You're following the rules. It makes sense. But here you have to remember that the root is going to be sulfur. You just use sulfur for the root. So sulfate, the root is going to be, I'm going to drop the AT ending, but I'm going to take the word sulfur. So instead of SULF for the root, I'm using the name of sulfur. And then we add IC to that. So, and then we have acid. Oops. like so. So this is sulfuric acid. So when you have SO4, and the same goes with SO3, if this was H2SO3, SO3 would be sulfite, right? SO3 2 minus would be sulfite ion. Drop the IT ending. You might think it's sulfus, right? Sulfus acid, but again, that would be the wrong root. So you have to remember that sulfate and sulfite become sulfuric and sulfurous acid. So you got to watch out for that. Another one you got to watch out for is when you have something like H3PO4. So again, the way you would name it is you look at what the polyatomic ion is, PO4. That is, you should recognize as the phosphate ion. So you might say right. So again, phosphate, drop the AT ending, add IC, right? So you would think, oh, AT, oh, then that's going to be phosphic acid. Phosphic acid, right? Wrong again, right? So again, you have to remember the root of this particular uh, acid in this, or for this particular acid. If you have PO4 or PO3 for phosphite, you got to remember that the root is going to be phosphor, not phosp. So again, the root of sulfur is we just keep the name sulfur. The root of phosphorus is going to be phosphor. So we use phosphor as the root, and we add IC to that. So this would be phosphoric acid. Oops. Didn't give myself enough space. So here we have phosphoric, and then we would add acid to the end of this. So H2SO4 is sulfuric, not sulfic acid, but sulfuric acid. So sulfur is the root. You're going to add IC. And again, if this was H2SO3 sulfite, SO3 2 minus, that would be sulfite. Drop the ending. The root is sulfur. So sulfurous would be the right way to say this. So sulfurous would be H2SO3, sulfurous acid, H2SO4, sulfuric acid. H3PO4, that's going to be phosphoric acid. So phosphor is the root. So H3PO4 would be phosphoric acid, and then H3PO3 would be phosphorus acid, phosphorus acid. And so that, ladies and gentlemen, is how you name your binary and your oxy acids. I hope this was helpful. If you enjoyed this video, if this helped you in any way, then please like the video, share the video, hit that like button. Also, make sure that you subscribe to my channel. When you do, make sure that you click on that notification bell. And then when you do that, make sure you click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a question or a problem you need help with, put it down below. I would love to help you with that. Thanks for joining me, and have a great day.